ಇವತ್ತೇನ್ ಮಾಡ್ತಾ ಇದೀವಪ್ಪ ಅಂದ್ರೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ದ ಫಾಲೋವಿಂಗ್ ಅಂತ ನಮ್ಮ ಎಕ್ಸಾಮ್ಗಳಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ ಕೇಳ್ತಾರ. ಆ ಕ್ವಶನ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡುವಂತ ಕೆಲಸ ಮಾಡ್ತಾ ಇದೀವಿ. ಹಂಗಾದ್ರೆ ಡಿಫ್ರೆನ್ಸಸ್ ಆಫ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ಬೋದು ಅಥವಾ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ದ ಫಾಲೋವಿಂಗ್ ಅಂತ ಅನ್ಬೋದು. ಹೌದಾ, ನಾನು ಆಲ್ರೆಡಿ ಕನ್ನಡದಲ್ಲಿ ವ್ಯತ್ಯಾಸಗಳು ರೀತಿಯಾಗಿ ಬರ್ತಾವ, ಅವುಗಳ ಜೊತೆ ನಿಮ್ ಜೊತೆ ಏನ್ ಮಾಡಿದೀನಿ ಅಂದ್ರೆ ಅದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡುವಂತ ಕೆಲಸ ಮಾಡಿದೀನಿ. ಹಾಗಾದ್ರೆ ಈಗ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇರುವಂತಹ ಕಾನ್ಸೆಪ್ಟ್ ಒಂದ್ ಸ್ವಲ್ಪ ಕನ್ನಡ ಮತ್ತು ಇಂಗ್ಲಿಷ್ ಮಿಕ್ಸ್ ಕಂಗ್ಲಿಷ್ ಹೌದಾ, ಕಂಗ್ಲಿಷ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಅಲ್ಲಿ ನಾನು ಏನಪ್ಪಾ ಅಂದ್ರೆ ವಿವರಣೆ ನೀಡುವಂತ ಕೆಲಸ ಮಾಡ್ತೀನಿ. ಹೌದಾ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿ ಇಂಗ್ಲಿಷ್ ಅಲ್ಲೇ ವಿವರಣೆ ನೀಡಿರ್ತೀನಿ. ಬಟ್ ಎಲ್ಲಿ ನನ್ನ ಗಾಡಿ ಸ್ಟ್ರಕ್ ಆಗ್ತದೋ ಅಲ್ಲಿ ಕನ್ನಡವನ್ನ ಬಳಸ್ಕೊಂಡಿರ್ತೀನಿ ಅಂತ ಹೇಳ್ತಾ, ಹೌದಾ. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಫಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಏನಿದೆಪ್ಪ ಅಂದ್ರೆ ಸ್ಯಾಚುರೇಟೆಡ್ ಮತ್ತು ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಅಂತಿದೆ. ಓಕೆ, ವಾಟ್ ಆರ್ the what things called as saturated and what are the things called as the unsaturated. Whatever the hydrocarbons contains a single bond, those are called as the saturated hydrocarbons, and whatever the hydrocarbons contains a double or triple bonds, those are called as the unsaturated hydrocarbons. Saturated hydrocarbons are less reactive. What? They are single bond. Okay? Then unsaturated hydrocarbons are more reactive. Okay, they easily undergo oxidation. That's why they are more reactive. An example for saturated hydrocarbons are alkanes and cycloalkanes. Example for unsaturated hydrocarbons are alkenes and alkynes. If we think that another ಏನಪ್ಪ ಅಂದ್ರೆ ವ್ಯತ್ಯಾಸ ನೋಡೋದಾದ್ರೆ ಸಂಗ್ರಹಣಾ ಯೋಗ್ಯ ಕಾಲಾವಧಿ ಅಂತ ಕರಿತೀವಿ ಅದನ್ನ. ಪ್ರೆಸರ್ವೇಟಿವ್ ಟೈಮ್, saturated hydrocarbon contains more. Preservative time is very less in where unsaturated hydrocarbons. That's why by additional reactions ಸಂಕಲನ ಕ್ರಿಯೆಗಳನ್ನ ಮಾಡೋದ್ರ ಮೂಲಕ ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಗಳನ್ನ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಸ್ಯಾಚುರೇಟೆಡ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಗಳಾಗಿ ನಿಕ್ಕಲ್ ಪ್ಯಾಲಡಿಯಂ ಕ್ಯಾಟಲಿಸ್ಟ್ ಅನ್ನ ಬಳಸೋದ್ರ ಮೂಲಕ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಹೈಡ್ರೋಜನ್ ಅನಿಲವನ್ನ ಹಾಯಿಸೋದ್ರ ಮೂಲಕ ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಅನ್ನ ಸ್ಯಾಚುರೇಟೆಡ್ ಆಗಿ ಪರಿವರ್ತಿಸ್ತೀವಿ. This is the difference between saturated and unsaturated hydrocarbons. Next, homologous organs and analogous organs. Okay, these are the organs which have a common origin but perform a different functions. Those are called as a homologous organs. Then analogous organs, these are the organs which have different origin but perform a similar functions. Okay, those are called as analogous organs. ಹೌದಾ, ರಚನಾ ರೂಪಿ ಅಂಗಗಳು ಮತ್ತು ಕಾರ್ಯರೂಪಿ ಅಂಗಗಳು. Okay, then the wings of birds and forearms of humans, both they are similar, looks similar, that's why they're homologous but perform different functions. Okay, the forearms of humans are do different functions, and the birds forearms they perform for fly. Then analogous organs, wings of a bat and wings of a butterfly, both if you see the organs of a butterfly and if you see the organs of a bat, structurally they are differ, but both are helpful for fly. Okay, next one, oxidation and reduction. Addition of oxygen is called as oxidation, where to element or to compound addition of oxygen is called oxidation. To element or to compound removal of oxygen is called as a reduction. Then in oxidation, loss of electrons takes place. In reduction, gain of electrons takes place. It is the process of removal of hydrogen. It's not given in textbook, but the process of removal of hydrogen from an element or from a compound, it is called as a oxidation. The process of addition of a hydrogen to compound or element, it is called as a reduction. Okay. Now we move towards next, that's arteries and veins. Okay, arteries, they carry blood away from the heart, means they carry blood to all parts of our body. They carry blood where all parts of the body from heart. Okay, then veins, they carry blood towards the heart. They brings the blood from all parts of the body to heart. They brings the blood from all body parts to where? To heart. Okay, then arteries have a thick walls without walls. Arteries have a thick walls without walls. Veins have a thin walls and they have a walls. Why they have walls? To stop the backward flow of blood. Stop the backward flow of walls. Wherever walls are there in heart also, in blood veins also. Okay, why? To they prevent the backward flow of blood. Next, concave mirror and convex mirror. Okay, concave mirror is called as a converging mirror. Convex mirror is these are called diverging mirrors. Why they are called converging and why they are called diverging means when we pass a light rays, when we pass a light rays parallel to principal axis, the light rays converges at a point. Where they converges? They converges at a principal focus. So what concave mirror is called as a converging mirrors. Convex, when we pass a light rays parallel to principal axis, the light rays diverges and whatever the diverge points imaginarily converges at one point, that's also principal focus. But here light rays are diverged. That's why convex mirror is called as a diverging mirror. Convex mirror is called as a diverging mirror. 1 minute. Then in concave mirror, inner surface acts as a reflecting surface. In a convex mirror, outer surface acts as a reflecting surface. Then in concave mirror, what real and virtual images are produced? In convex mirror, all images are virtual. All images are virtual. In a concave mirror, whatever we discussed, real and virtual, at infinity, beyond C, at C, in between C and F, at F, these all cases real images are produced. But whenever we can keep a object, whenever we kept object in between the principal focus and pole of a mirror, in that case virtual image is produced. That's why I produce a real and virtual images. Which one? Concave mirror. And convex mirror, all cases produces a virtual images. Next, concave lens and convex lens. Concave lens and convex lens. Okay, both are concave lens and convex lens. Both are the transparent lenses. Okay, they are thin at the middle. Concave lenses are thin at middle and thick at the edges. Concave lenses. Convex lenses, it is a thick in the middle and thin at the edges. Thin at the edges. Then concave lenses are called a diverging lens. Already I explained in concave mirror and convex mirror. When we pass a light rays parallel to principal axis, the light rays are diverged. That's why concave lens is called as a diverging lens. Then convex lens, when we pass a light rays parallel to principal axis, the light rays converges at a point where in principal focus. That's why it is called as a converging lens. Always produce concave lens, always produces a virtual images. Then convex lens, it produces both real and virtual images. I already told for you what when we kept the object beyond, sorry, at infinity, then beyond 2f, in between f and f are on f. Okay, all these cases real images are produced, and when we keep an object in between f and o, principal focus and optic center of the lens, then the image produced is virtual. Image produced is virtual. Next, AC dynamo, DC dynamo. AC dynamo, DC dynamo. Okay, AC alternating current produces a alternating current. DC direct current produces a direct current. Then AC dynamo, armature rotates with the slip rings or full rings. Armature rotates with the slip rings. Then armature rotates with the split rings. Where? In DC dynamo. Next, the direction of current changes in every half revolution. The direction of current changes in every half rotation or revolution. The direction of current does not change. The direction of current does not change. Where? In DC dynamo. Or the direction of current turns into backward flow or in single direction. Reversed. Every half cycle, the direction of current reversed in DC dynamo. Next, corrosion and rancidity. The metals are long time exposure to moisture or acids, they become corroded. It's called as a corrosion. Then rancidity, the process of oxidation of oils and fats produces a foul smell. That's called as a rancidity. That's called as a rancidity. Then all metals, maximum all metals undergo a corrosion. Rusting of iron is example for corrosion. Then rancidity, food atoms, oils and fats, whatever the food made from